You want this recording also? Fine.
For future reference. Thank you, sir.
Yeah, fine. Okay, you can ask me any questions now. Now it is your turn. Now the session is open for you. So first of all, I would like to start with your doubts. Then at the end, I can solve some of the problems which I have documented today to discuss. First, I would like to clarify all your doubts. If time is there, then I can discuss. Yeah, you just tell me any questions if you have. Start with one by one. So we'll go chapter by chapter. Okay, let me make a fresh presentation. Yeah.
Sir?
So let us go chapter by chapter. If anybody is having doubt, we can start. Yeah, please ask.
Actually, I have a question from the antennas topic, sir.
Yeah, sure. Tell me.
So I have a problem that I'm not able to solve.
Okay.
So shall I
Okay, it
dictate
is
the
related to
problem?
what concept to tell me. I will give an approach whether it can be possible now, or otherwise you can share me the question. Not a problem.
Yes, sir. If a short antenna of length 1 centimeter
Uh,
is excited with 100 milliampere current at 1 gigahertz, then the magnitude of the tangential electric field along the antenna bore side at a distance of 100 lambda is.
No, what is the question? Once again, the magnitude of?
The magnitude of tangential electric field along the antenna broadside, bore side at a distance of 100 lambda.
100 lambda. Yeah.
Yes, sir.
Basically, see, these kind of problems you have to compare. At one is a wavelength you are. You can assume that the medium is free space. Anything about the medium he has given?
No, sir.
He has not given anything?
No, sir, it's not given.
So I will tell you what is approach I can do. I didn't remember whether I have discussed about the Friis equation or not. Friis transmission equation in the antennas? Okay, no problem. You see, when you pass some current through this antenna, it is going to create the power, right? So what is the power radiated by the antenna is basically the current I square into radiation resistance. Am I right?
Yes, sir.
Yeah. So this is at a distance of what distance you are telling?
100 lambda.
100 lambda. Yeah. So that of D, what is the power density? The power density will be in terms of electric field. If you're talking about E square by 2 eta. Have you remembered the power density formula? 1 by 2 into E cross H conjugate in the wave propagation I told you.
Yes.
Correct? Okay. And because whatever the type of antenna, did he mention anything about the type of antenna like isotropic or dipole?
No, sir. From the length given, I found that it is a Hermitian.
What kind of antenna? See, he's telling that it is just
Short
only a
antenna.
kind of wire kind of antenna.
Short antenna.
Yeah. So basically what will happen, the wire kind of antennas will be omnidirectional in pattern. Okay. So all this wire omnidirectional. So if you take the coverage will be something like a sphere, you can assume. So the coverage of the dipole antenna will be omnidirectional. Okay. If you take omnidirectional, you can multiply with 4 pi r square. R is the distance of the observer from the antenna.
Yes, sir.
Okay. So in that case, what will happen? You know what is the current? 100 milliamps.
Yes.
And you know what is the radiation resistance? To find out the radiation resistance, I would have been given some concepts to you, right? If the length of the element is lesser than lambda by 10, this is called your Hertzian dipole. Okay. Radiation resistance will be E pi square into dl by lambda whole square. Okay, so what you can do right now, you know what is the frequency, right? Based on the frequency, you can estimate what is the wavelength.
Yes.
Are you getting my point? Yeah. So you calculate the wavelength. Then you compare what is the length of this. So let us calculate right now. So lambda, you are going to get around 0.3 meter, 30 centimeter, right?
Yes, sir.
Yeah. So what is the length of your antenna? It is equal to 1 centimeter, which is equal to lambda by 30. Correct? So basically a Hertzian dipole, because your
Yes.
length is much lesser than your lambda by 10. Okay, so you calculate radiation resistance in this case. You know what is the length of the antenna. You calculate radiation resistance. So radiation resistance is known and current is known, and you are supposed to find out your electric field, and impedance of free space is 120 pi, and the distance already you know it is 100 lambda.
Okay,
Is
sir.
it clear? Yeah.
Clear.
So you can do the
Yes.
calculation and just cross check your answer.
Okay, sir. Thank you.
Yeah. So others, what about others? No, let me start with the antennas only, since we have started with the antennas. First thing, I will put it in a different simple things. First of all, you will have a different type of antennas, and everybody has to notice that the types of the antenna and the radiation pattern is not important in gate. Okay. But actually, what is important in gate related to the antenna theory is the antenna parameters. Okay. We have discussed about, I remembered something like isotropic radiator. And the next thing is the radiation intensity. And the third one is the power density. And especially the very important parameter is the gain. And in this, there are two type of gains are there: directive gain and there is a power gain. And the next thing is the beam width. And the final thing what I have discussed is basically the antenna arrays. Okay, we have seen the two element array case. So the problems related to the antenna arrays. These are the only topics which you are supposed to concentrate. So as you know that the antenna subject is very vast. See, you can cover the whole subject in the entire semester, but the things required related to gate is only about these basic parameters. Of course, there are at times you can expect the questions will be out of the syllabus that none of the people can be able to answer, right? So everybody will be like that. But as per the syllabus is concerned, it is mentioned like basics of antenna parameters. Okay. So try to concentrate only on this topic. And if any question is given in this particular topics, you should be able to solve. Okay. And maybe I would have been forgotten to mention what is the radiation resistance, right? So I will give the conclusions. You make a note of it. Okay. Suppose if you have any dipole antenna, so let us say the length is dl. So I don't know whether I have given the equations or not. If the length of the element is lesser than lambda by 10, the radiation resistance formula is 80 pi square dl by lambda whole square. And if the length of the element is between lambda by 10 and lambda by 2, the radiation resistance is approximated by 20 pi square dl by lambda whole square. Suppose if your length of the antenna is half of the wavelength, your radiation resistance is 73 ohms. For a half wave dipole antenna, the radiation resistance is 73 ohms. Okay? And similarly, suppose if you have connected n number of dipoles in an arrangement, so the radiation resistance will be n square into 73. If you connected n number of dipoles in parallel, the radiation resistance will be n square into 73. Okay. These are all basically, there is a lot of derivations behind that. But you try to remember this. Maybe you can able to solve some of the questions. Because why I was mentioning this one was, This is very important for the PSU examinations are concerned. Maybe for the gate point of view, you can say it is less. Okay? But for the PSUs, it is quite very important. So just make a note of it. And you can include it in your short notes. Okay. Any other questions in the antennas? We'll start with the antennas, then only you can go back. So what about others? How many of you completed the whole EMT part? Revision? Whatever I said in the class. So I want to know the answer. How many of you completed the syllabus? Half done. What about others? I want everybody to answer. Or otherwise there is no meaning, right? I want everybody to answer genuinely. Okay, if you are not done, just say not done. If you have completed at least 30%, you say 30% completed. I want everybody to answer. Okay. Okay, I don't know. So other people are not responding. Only I got the answers from 3 people. Fine, but actually I already told you. This time you should be able to complete all the topics. I don't know what is the reason. What to do? Okay, ask me any questions. Yeah. Yes, yes.
I had a few doubts. That experiment you had done.
Which
In
one?
that, so like S parameter.
Okay. Okay. Fine.
So in that, like you did 2 sums. In that case, they were both symmetrical. I wanted to know, like, in case if they're not symmetrical, then how do we solve the sum? Like any one example or something.
Let me start with this. I would have been discussed a problem related to S parameters by assuming
Yes,
it like this, right? This is a matrix. I have done this for this.
Yes, sir.
Maybe for 50 ohms. This is also 50 ohms, and this is also 50 ohms. Have I done for
Yes.
this also, series branch?
Yes, sir. You've done this sum.
Both, for both series and parallel?
Yes, sir.
So if it is non-symmetrical
Sums
also, what actually you have to do? Suppose, let me explain in this only, then I will go back to the non-symmetrical case. Okay, fine. So first of all, you know, to calculate S11, that is nothing, if you remember this, that is B1 by A1, provided A2 is equal to 0, right? So this is your A1,
Yes, sir.
and B1 is coming out of port 1. Similarly, this is your A2, and this is your B2. So whether it is symmetric or non-symmetric, the procedure is same. So what I was doing it here, in this particular case, to calculate the value of S11, when you look from this particular side, your A2 has to be equal to 0. Okay? So when you look from this particular side, A2 is something like the reflection from the port 2. Agree with my point? When you are looking into the circuit from this side, A2 is appearing to be a kind of reflection from the second port.
Okay. Yes, sir.
Yes. So if I want to have A2 is equal to 0, with what impedance you have to terminate? Your reflections will be 0, provided your impedance will get matched, right? Correct?
Okay.
You have to terminate with 50 ohms. So what is the procedure right now? When you are looking from this particular side, let me say the Zin value. So what is the effective impedance here right now?
20.
Yeah, 50 ohms and 50 ohms in parallel. So the effective impedance will be 20 ohms, correct?
Yes, sir.
So S11 is the reflection coefficient at port 1. So what is the reflection coefficient? That is due to the change in impedance Zin minus Z0 by Zin plus Z0. Agree? So what is the value you are getting? 25 minus 50 by 25 plus 50. Okay. Now I will come back to our case. Okay. One port is having 50 ohms. The other port is having 25 ohms. Second port. How to calculate S11 in this case? The procedure remains same. But what is the change here? Can you tell me now? Is it a symmetrical or non-symmetrical circuit? We're looking at this.
Unsymmetrical.
Yeah, because impedance is 50 and output impedance is 25. It is a non-symmetrical. Okay. And to calculate the value of S11, what should I do now? Terminate the load impedance. Yeah, tell me.
So
No,
we'll
in this,
consider 25.
correct, it is 25. Why doubt? It is simple, right? Here I have terminated with 50 ohms because my port 2 impedance is also 50. The only change here was instead of terminating with 50, you have to terminate with 25. So now what is the result right now? So the effective input impedance here Zin. If you look at the value of Zin, that is 25 in parallel with 50. That is the only change. Okay, so the rest of all simple. Understood?
Okay. Yes. Yes, sir.
The only was you have to connect a different loads. When it is a non-symmetrical, you have to see at that particular port what is the impedance. If it is 50 ohms, you terminate with 50. If it is 25 ohms, you terminate with 25. So in this case, whatever the S you are getting, it is not equal to S22. Because if you want to calculate S22, what you have to do? Here you have to terminate with 50 ohms and you have to look at from this particular side.
Okay. Yes.
Whether
Sir.
I have answered your question?
Yes. Yes. Fine.
Yeah. The only thing was change
So,
in the
sir.
impedance. Yeah.
Okay. So now, for S22, we'll consider Z0 to be 25.
For S22.
Yes, sir. S22.
For calculating S22, you have to look at from the second, right? So at
Yes.
that time, the first port has to be terminated with 50 because port 1 is having 50 ohms.
Yes. Okay.
Okay. S22 means what you tell me? You are looking into the circuit from the port 2. So write down the definition if you want. S22 is equal to B2 by A2 provided A1 is equal to 0. Am I right?
Yes, sir.
Yeah. When is your A1 will be equal to 0? When you look from this circuit, this side, second port, your A1 will be 0 provided the load impedance will be same as your characteristic impedance. Okay. So you have to connect a load of 50 ohms only. Then impedance is matched. So you can see right now there are no reflections here. You can say A1 is equal to 0 because impedance is matching here. Agree?
So in case like that, now here you have taken the Z0 in the actual question. You've taken the Z0 to be 50 ohm. So if that was not 50 ohm.
If it is not 50 ohm, let us say 100 ohm.
Okay.
Port 1 impedance. And then you terminate
Okay.
with 100 ohms.
Okay.
Okay. Whatever the port 1 impedance is there, you have to terminate with the same load. Then only you cannot have any reflections, right? If the impedance matches,
yes,
you cannot have any reflections. That is the agenda here. So since port 1 is having 100 ohms, if you say, you terminate with 100 ohms, then you will not have any reflections.
Okay, so fine.
Yeah. So any other questions? Others? See, any questions?
Sir?
Yeah.
Sir, for the circular waveguides, will the plane of incidence will be the same XZ plane?
Circular waveguides plane of incidence will be same thing in the Z direction. The wave is propagating in the Z direction. So this is your circular waveguides, right? And the axis of the waveguide is Z direction. But what will happen here also same thing. It will get multiple reflections and it can pass. Okay. So the actual propagation direction, if you are resolving it that one, you can have one Z component and one rho component. Because it is a cylindrical, right? So you can have a rho variation as well as a Z variation.
Okay, sir.
Yeah. So let us discuss anything related to waveguides. So if you don't have any questions in the antennas, just come back to the waveguides. Especially in the waveguides, the only intention here is the problems are quite simple in waveguides because we have seen a lot of mathematics analysis in that. But the only thing was all the problems are mostly based on your 4 formulas. Okay, so let us try to recollect what all the formulas it is there. So if it is a parallel plate waveguide, the cutoff frequency is MC by 2A. Okay, and if it is for rectangular waveguide, the cutoff frequency is C by 2 root M by A whole square plus N by B whole square. And the remaining thing, everything is same. The phase velocity is equal to wavelength into frequency. And wave impedance for TE and wave impedance for TM. 120 pi by cos theta and 120 pi into cos theta. So all these equations are going to be same. There is no change in the equations. Okay, just we can discuss for some time if you had any problem, any doubts. And the very important concept is nothing but your understanding of TE, TM and TEM. I'm not asking you to memorize any of the equations, but you should be understand what is transverse electric, magnetic and transverse electromagnetic. You should be very clear with the definitions. Okay. More questions here? So otherwise one thing we can do, we'll try to solve the problems also. Is it fine? Because you are not asking any questions means what should I do? I will start with the problems. Then simultaneously we can discuss the related topics also. Is it fine? Or you want to, if anybody is having doubt, you can clarify, then only I can start the problem. Yeah. So my role is nothing. I will display the question and at least one of you should tell me the approach, how to do. Okay. Then everybody will start doing it. Okay. So you can see this is a problem related to transmission lines. Okay. See the first problem. Consider the following circuit shown below. The length of the transmission line to ensure the maximum power transfer to the load. Okay. This is your basically your source and this is your load. Okay. So load impedance is 400 ohms. Okay. And your source impedance is 200 ohms and the characteristic impedance of this line is 200 ohms. Okay. So this is the transmission line he is using to match the source and the load impedance. Okay. So what should be the length of the line in that case? Okay. At least one of you to tell the approach what to do. If I solve the problem, there is no meaning. So the session is open to you right now. You should be able to solve. And you can see this is the line which is placed near to the load. So can anybody give the approach? Yeah, at least one of you should be able to tell. For maximum power transfer, what should be the length of the transmission line? I'm asking this one. See, this is a kind of problem which I have not discussed in the class. I thought you should apply your knowledge and you should be able to do. So I'll tell you, there is a maximum chance that the students will do mistake, because whenever I can say the maximum power transfer or impedance matching, you may think that it is a lambda by 4 line. Okay, but in this case, it is not lambda by 4 line. Okay. Can you why I am telling you it is not a lambda by 4 line? Because if it is a lambda by 4 line, I already told you in impedance matching, the characteristic impedance is equal to square root of Z0 into ZL. Okay, here you can see that your source impedance is 200 ohms and your load impedance is 400 ohms. So what is the value you are getting? 200 into root 2. But what is the characteristic impedance of the line I have given? It is 200 ohms. It is not 200 into root 2. So this is not a lambda by 4 line. Is it clear for everyone? Are you getting my point? What I am saying? Just answer. If it has to be a lambda by 4 line, the characteristic impedance has to be 200 into root 2. But I have given characteristic impedance is 200 ohms. So definitely it is not a lambda by 4 line. Confirm, are you getting my point? Are you able to hear my voice? Yeah, then you should have been told, right? Just reply whenever I was asking, or otherwise I am not getting any feedback. So the question is here, it is not a lambda by 4 line. So when you want to have a maximum power transfer, the effective impedance looking from this terminal has to be equated to 200 ohms. Okay, when you look into this particular side, whatever the effective input impedance, that should be equal to 200 ohms. Okay, then only your impedance gate can match and you can transfer the maximum power. But I don't know what is the length of the transmission line. And by seeing the characteristic impedance, I can say that this line is a lossless. So what is the input impedance for a lossless line? You have to start with the generalized equation. I don't know how many of you remember. So Z0 into ZL plus JZ0 tan beta L by Z0 plus JZL tan beta L. So this impedance has to be equated to 200 ohms. So by comparison, your ZL is 400 ohms and Z0 equal to 200 ohms. So ZL is known and Z0 is known. So you can get what is the value of beta L. So once the value of beta L is known, you can calculate the length of the line. So all of you please try and tell me. So Z0 is 200 into ZL is 400 plus JZ0 tan beta L divided by Z0 is 200 plus JZL tan beta L is equal to 200. So 200 gets cancelled. So what is the condition you are getting? 400 plus J tan beta L is equals to 200 plus J into 400 tan beta L. Okay. So what is the answer you are getting? 200 J tan beta L is equal to 200. And if you take the magnitude on both the sides, your tan beta L is equal to 1. So your beta L has to be pi by 4. So your electrical length has to be 45 degrees. Can anybody say how to calculate beta? Can anybody say how to calculate the value of beta? Quickly reply. Beta is equal to 2 pi by lambda. So you know that beta is 2 pi by lambda into L is equal to pi by 4. So your length has to be exactly lambda by 8. So in this case, I have used a length of the transmission line which is 1 by 8 times of your wavelength. So how to calculate the wavelength right now? The wavelength is equal to C by F. Because I have given the phase velocity is equal to 3 into 10 power 8. And this is of the form 2 pi F. Right? You can see whatever the source I was applying, this is a form sine omega t. Okay? So from this omega, you can calculate the frequency. So this is equal to your omega, and if you divide with 2 pi, that is your frequency. So that will be 50 mega. You can verify if you want. So whatever the value given, divide with 2 pi, this will be your frequency. So then from this you can calculate what is the wavelength, and the length of the line has to be lambda by 8. Okay. So any questions here? So these kind of problems are important because whatever I discussed in the classroom is purely related to maybe lambda by 4, or it is lambda by 2, or maximum up to lambda by 8. Okay. So I thought you would have been done more practice, but I'm not seeing that. Okay. So just discuss what all the concepts which you feel more difficult in transmission lines. Just let me know what all the topics you felt more difficult. Or anything needs to be explained, we can have a discussion now. Better if you turn on your microphone and you can speak, at least some of you. Okay, see the next problem. I hope you'll be able to problem. This is related to the antenna. Okay, so there is a power of 100 watts is radiated from the isotropic radiator. Then what is the power radiated per unit solid angle? What is the power density at a distance of 10 kilometers from the antenna? So quickly tell me, if this isotropic radiator you know that this is going to generate in all the directions. So 100 watts will be distributed in all the directions. So tell me the power radiated per unit solid angle. So what do you mean by that? Power radiated per unit solid angle? What is the term called? In antennas, what is the term called? Power radiated per unit solid angle is called what? This is basically called your radiation intensity, right? So the power is total power radiated power is equal to 100 watt. And for isotropic radiator, what is the solid angle? What is the solid angle for isotropic radiator? I told you, since isotropic radiator covers a full sphere, the solid angle is 4 pi steradians. Okay, so the answer will be 100 divided by 4 pi watts per steradian. You can cross check your answer. Okay, and the power density is simple. Whatever the power radiated divided by 4 pi r square. So you know that 100 watts is the power radiated and at a distance of 10 kilometers. What is the power density? Okay, have you revised or not? I'm not getting. I'm in a complete confused state right now because I'm not getting any answer. Okay, let me see whatever you have revised. Let us go to the next problem. At least this question you try to solve. All of you. This is related to the polarization. So let's try from your side. So this is the electric a uniform plane wave propagating in free space along the positive x direction. Okay. Then find what is the frequency and polarization. First, everybody calculate the frequency. So tell me what is the frequency you are getting. So by comparison, you can see beta is equal to 25, right? This is of the form e power minus j beta x. So beta is equal to 25, which is 2 pi by lambda. Okay, so your lambda is equals to 2 pi divided by 25. Since the wave is propagating in free space, the wavelength is same as 3 into 10 power 8 by the frequency. So you can calculate what is the frequency you are getting. So the frequency will be 3 into 10 power 8 into 25 divided by 2 pi. Okay, so tell me what is the value. Just try. Tell me quickly, what is the value you are getting? Are you able to hear? Is my voice audible? Hello. Yeah, you tell me quickly, what is the frequency you are going to get? So you can verify the frequency is 1.2 giga. Okay. You can see here, this is a polarization. If anybody not understood, once again I was explaining, this is a very important concept for gates. Okay. So in this particular equation, it has been not given the variation of time. Okay. So one planar component is y, the other planar component is z. Okay. So first you multiply with sine omega t for the first planar component. And for the second planar component also, you should multiply with the same thing. So the first planar component magnitude is 1, you can see here. And the second planar component, j is getting added. So as you know that whenever you are having j, it is going to contribute for 90 degrees phase shift. So one component is sine omega t and the other component is equal to, so sine of 90 plus theta, you can say cos omega t. Then you plot the graph between y and z. So as per the first thumb rule, the horizontal direction and the vertical direction, that you should take it as a out of the board. So y is horizontal, z is vertical. So the outside of the board will be your positive x-axis and negative x-axis will be into the board. Okay. So let us calculate at time t is equal to 0. Okay. So what is the value of y you are getting? 0 and 1. Okay. 0 and 1 may be somewhere here. Okay. At time t is equal to t by 4, your omega t will be pi by 2. So y will be 1 and z will be 0. So 1 comma 0 may be somewhere here. Okay. At time t is equal to t by 2. So your omega t is equal to pi. So y is equal to 0 and z equal to minus 1. Okay. 0 minus 1 will be here. Now you can see here, as the time advances, t equal to 0 here, t by 4 here, t by 2 here. So as the time advances, the locus is moving in a clockwise. Now to define whether it is a right circular or left circular, you can apply the second thumb rule. So as per the second thumb rule, you have to place the thumb in the direction of propagation. As you can see here, the direction of propagation is positive x. So as per your convention, the positive x should be outside the board. Okay. Now you start with any of your hand and make sure that your thumb should be outside. Okay. So when you start with your right hand, all of you, place the thumb outside. So the movement of the other fingers is anti-clockwise. So the right hand is not satisfying. So do the same thing with the left hand. Place the thumb outside. So the movement of your fingers is matching in accordance with the loop. So since your left hand is satisfying, the answer is left circular polarized. Okay, you just ask me if you still have any questions, I can explain in this. This is a very important topic. Okay, so let us go to the next problem. So see the problem. This is a problem related to your oblique incidence. These kind of problems are very important. So assume that there is a plane wave in free space with an electric field. This is the one. Is incident on a non-magnetic dielectric slab of constant epsilon r equal to 3, which occupies the region z greater than 0. Then what is the angle of transmission? Okay, so this is the interface located at z equal to 0. And the wave is entering from the free space. You can call it as a free space. So you know that permittivity will be 1. And the second medium is your dielectric medium. And consider that this is your normal. So this is your theta I and this is your theta t. Okay. So in this particular region, your z is greater than 0. So this is your dielectric where z is positive and epsilon r is equal to 3. Okay. As you can see that this is the interface located at z equal to 0. So can you tell which will be the perpendicular direction? What is the perpendicular direction here? So when I say z equal to 0, which is your perpendicular direction to that? Z equal to 0 is your xy plane. So you can consider this is your negative z and this is your positive z, because in the dielectric medium your z has to be positive. So this is your z component. If you look at the equation clearly, there is a propagation constant in x direction and there is a propagation constant in z direction. So what is the condition? This is your resultant propagation constant. You can call it as beta. Okay. So if you resolve this vector, this will be along beta x. As you can say, this is your xy plane. You can consider it as x-axis. So this is your beta x and this is your beta z. Now all of you can look at a triangle like this. You can have a look on this particular triangle. So what is the value of beta z? Beta z is equal to beta into cos theta I. Right? So what is the value of beta? You know that beta x is equal to 3 and beta z is equal to root 3. You can see here beta x is equal to 3, beta z equal to root 3. So what is the resultant propagation right now? Root over beta x square plus beta z square. Okay, so tell me what is the value? Beta x square is equal to 3 square, beta z square equal to root 3 whole square. So you are going to get root 12. Right? Then you can find out what is the angle of incidence. So your value of cos theta I is equals to beta z by beta. Okay. And beta z by beta means beta z is equal to root 3 and beta is equal to root 12. Okay, so from this you can calculate what is the value of theta I, right? Okay, once the value of theta I is known, we can use the Snell's law. Sin theta I by sin theta t is equal to root epsilon r2 by epsilon r1. Okay, so using this you can know what is the value of theta I. So once you know the value of theta and you know epsilon r2, which is nothing but 3, and you know epsilon r1 at 1, so you can calculate what is the value of theta. Okay, you know the epsilon r2 and epsilon r1. So from this you calculate what is theta I. then you will automatically know what is the value of theta t. So feel free to ask any questions if you have. This is kind of problems are very important, oblique incidence. So have you understood the problem? The only key point here is whatever I have given it here, the resultant propagation you should be resolved into two components. One will be along x direction, the other one will be along z direction. So if you calculate the resultant propagation, this will be the square root of beta x square plus beta z square. Okay? So you know the resultant propagation constant and you know what is the value of beta z. So you can easily find out what is theta I. Then you can use the Snell's law to find out theta t. Shall I go to the next problem? Okay, try this problem and tell me. The magnetic field along the propagation direction inside a rectangular waveguide with the cross section shown in the figure. I think figure has been not shown. This is something like this. So A is your dimension and B is your width. Okay. So this is the magnetic field intensity. Then find out what is the phase velocity. So if you look at the equation, I think you would have been remembered. This is your m pi by A and this is your n pi by B. Okay. By looking at the equation, m pi by A is equal to 2.094 into 10 square and n pi by B is equal to 2.618 into 10 square. So everybody calculate what is the cutoff frequency. The cutoff frequency is equal to C by 2 root over m by A whole square plus n by B whole square. Okay, you can multiply with pi and divide with pi. Okay, this will be m pi by A whole square plus n pi by B whole square. Okay. Because we know all the values m pi by A straight away and n pi by B, you calculate what is the cutoff frequency you are going to get. Okay. Just you can quickly calculate what is the value you are getting. So you can take 3 into 10 power 8 divided by 2 pi root over 2.094 into 10 square whole square plus 2.618 into 10 square whole square. Okay. So what you are going to get 3 into 10 power 10 divided by 2 pi root 2.094 whole square plus 2.618 whole square. So simplify this value. So tell me quickly what is the value cutoff frequency you are getting. Tell me quickly what is the value you are getting. Okay, you can verify it is of 16 gigahertz. Okay, I felt like I am writing the exam. You are the participants. Fine. And what is the frequency of the signal you can see? So by looking at the equation, your omega is equals to 6.283 into 10 power 10. So your frequency will be divided with 2 pi. Sorry. So you can see here, whatever the frequency, operating frequency is lesser than your cutoff frequency. You can see you got the cutoff frequency is 16 giga. So do you think that the wave is propagating? If we pass a frequency of 10 gigahertz and the cutoff frequency is 16 gigahertz, does the wave will allow? Is the waveguide will allow the signal or not? Tell me quickly. Will the waveguide allow if the frequency is lesser than cutoff frequency? Will it allow the signal or it will reject the signal? Excuse me, are you there? Will the waveguide allow the signal if the frequency is lesser than cutoff frequency? So if the frequency is lesser than cutoff frequency, the wave will not propagate. So the propagation is not possible. Okay. Since the propagation is not possible, your phase velocity is 0. Just confirm, are you able to hear my voice or not? If it is audible, why you are not replying? See, the class is not meant for me, right? If everything I am doing it, what is the thing? There is no point in continuing. If you are not prepared for the class, I already told you in the last 1 month back only. You should prepare and come class, or otherwise, what is the meaning? I am writing the exam, or you people are writing the exam? So when I ask any question, I was not getting any reply. Even for a basic concepts also, if you are not able to do, where is the mistake lies here? That is absolutely not correct. You just tell me when you are ready. I will organize a class on that day only. I thought you would be prepared by, or maybe some of the formulas you may not be able to remember, but the basic concepts only if you are not remembering, what should I do? You are taking the subject lightly. Should I proceed or what? Or you want whenever you are ready, then only I can discuss. I felt like I was attending the exam. And because these days I may not be able to clarify your doubts, I thought this will be the best platform where you can ask any doubts if it would have been practiced. But what I come to know was you have not practiced at all. Then why for this class is meant for? Just a minute, I will join Dinesh sir also in the line. I'll spoke to him. So in the meantime, if you had any doubt, please ask me. So I will ask Dinesh sir also to get joined in the discussion. So we can have a combined discussion. Where the problem? Okay, in the meantime, if you go to the previous next question, you please try to solve. So let us say this problem. I will see how many of you will be able to answer. Yeah, please share quickly. So in the S parameter matrix, so the dimensions will be n into n. Okay. So how many reflections coefficients are there and how many transmission coefficients are there? You know that basically S matrix is a square matrix. Okay. If you look at the diagonal side, the number of the reflection coefficient, how many you will have? The number of reflection coefficients. If it is having n number of ports, the reflection coefficients will be n. Okay. So other than the reflection coefficients, whatever you will have is your transmission coefficient. Okay. So the total size of the element is n square, and out of them, n will be your number of reflection coefficients. Okay. So the reflection coefficients will be n, and the transmission coefficient will be n into n minus 1. So this is nothing but my transmission coefficients. Yeah. So is it clear? Yes, sir has joined now. Sir, you can carry on, sir. First, I told you the problem already, right? You just speak to them for some time, then I will tell my version.